Yes, dear students. So today we are going to see the zones of protection, so protective zones. So this is that the overall view of the power system structure. So this is what is this? So this is that the overall view of that the power system structuring. So this is the structuring. So how the generator which can be protected and the bus bar will be protected and the transmission line will be protected. So each protection which may be going to consist of zones. So what is mean by zone? The protective area from one place to another place. The area covered by the protective device. Please note down the area area covered by the protective device. Okay, so that area which may be going to called as the what is that is the protection zone. So zones of that protection. Suppose if we are going to see with the help of a whiteboard, right? Assume basically, so this is that the system is a generator. Okay, so this is that the um, yes, so this is in as a memory problem. So this is that the generator, right? This is that the generator. Again, that the generator which may be going to connected with the bus. This is one bus. Again, we are going to that is that voltage, improve the voltage. Again, this is bus one. Again, this is bus two. This is bar one transmission line. Mm, This is for one transmission line. So again, that the transmission line which can be going to another transformer, right? So again, we are going to put that another one a distribution transformer. This is a step of a transformer. This is one step up transformer. This is a step down transformer. This is a distribution transformer. Okay, this is a distribution transformer. Okay, so these are all the things we have going to see, right? Now we are identify or fix the protection zone. Okay, so I am also going to put one cb circuit breaker for here, and I am also going to put one circuit breaker here, and here this is that the place. So this is the place I am also going to fix the cb circuit breakers, and it may be that is the feeder number of feeder is going on, right? So these are all that the feeders. These are all the feeders. Okay. Suppose and I am also going to fix that the city some where is that the whiteboard? Yes. This is that the city we are going to fix the different color. So assume here I am also going to take in that. So I am also going to fix one city here, Again, this is the CT. So assume, so this is that the CT we are going to be connected. Okay. Now, so again, this is the one CT which is available. So now I want to protect it. So here, this is one CT. So I want to protect the generator. My CT which can be going to sense the current flow. My CT will also going to sense the current flow on this position. This positions. Okay, suppose it can be that is the part which can be flow of current on this area. Okay, the current which may be flow from this to that place. So the CT which can be identified, that is the, suppose if the current in this place, in this place, this CT which can be accumulate, that is the, what is the fault or any other thing occur in this transformer or transformer losses which can be added. Okay, so it will take some distance or some other thing. So I am also going to cover the portion for this place to that place. Okay, so next, what we are going to do, that is, this is the portion. Please see, this is the portion we are going to cover. This is the portion we are going to cover. That is the area of the transformer. So this color we are going to protect the transformer for by using this cycle breaker, from this cycle breaker in between this line, and we are also going to introduce one, that is a CT, and if it is required based on this analysis we are introducing the another CT also, right? So similarly I am also going to place that the thing we are going to protect, that the system of a transmission line. Okay, transmission line I am also going to protect it. So similarly, what is that, that I am going to protection of the bus. So the bus protection, how we are going to accumulated the area, the bus can be protected. Suppose if the fault is occur in the system, any place, suppose the fault may be occur in this transformer or in this line. So both the place it may be occurred. So during the both the times, if it is, if the fault is occur in the both places or in any one place, we are going to trip or isolate this bus, isolate the this bus. So this bus is protected from this fault, that is, assume this is fault 1 and this is fault 2. So both the fault which can be protected from the suitable protective device. So that covering area is named as a zone. So this is a bus, BS bus 2, bus 2, bus 2 protective zone, bus 2 protective zone. Okay, so this is a zone. So now you can clarify. So if it is the any trouble is occur, immediately the system which can be protected. Simultaneously, if it is the any fault is occur here in the feeder, definitely our system which can be response in this area, this area, this city, right? So at the same time, uh, we are going to take into account for this transformer. Already we are explained from cover this CT, and then it can be flow in this direction. So based on analysis, each unit having a CV, each feeder having a circuit breaker here. Suppose it may be, and also this is having a separate CT also. See, this is available for the CT. So whenever the fault is occur here, this place or this place, This CT is not. Assume this is a distribution CT. That is a CTD, distribution CT. So whenever this CT is a failure to identify the fault transient or overcurrent or higher peak value magnitude of the current, again this CT which can be protect, okay, protect. So for that purpose, this line which can be overlapping, this overlapping which can identify the primary and secondary protection. Suppose if the fault is occurring in the feeder section, this CTD, distribution CT, will act as a primary protection. Again, this CT, as in this CT2, D2 will be act as a secondary protection. In case two, if the fault is occur in this place, please see, in this place. So here this CT or this CT will act as a primary protection, and this unit will be act as a secondary protection. Okay, so based on the fault occurring place in the power system transmission and distribution line, which may be going to the each protective device is act as a that is primary protection device or secondary protection device, or primary protection or secondary protection, and also a device which can be uh, cover the area, which means in the electrical area. It is not a geographical area, it is electrical area, which means that is what is that impedance. Normally current that is V divided by is equal to Z. So that is the impedance, the traveling impedance. So based on that impedance, we are going to see an fourth chapter, third and fourth chapter in detailed impedance relay, distance relay. We are going to study it in detail. Okay. So this is the base case for studying of the uh, what I'm so zone spaced protection and primary protection and secondary protection, bus bar protection. Now we are going to see that the part, so how it can come, right? So this is the generator protection, which means this protection is available CT which can be protect the generator. It is the primary. Yes, pointer. Yes, this pointer. Yes, this is that the primary. This is the primary. At the same time, if it is the this CT will act as a secondary protection of this generating unit, which may be connected into the bus bar. Okay. Okay. So this entire session will be act as a LV switch gear protection at the section of bus. So the next we are moved to next way. So in this next way, that is the transformer. So assume that is production of that voltage is 11 kV. This 11 kV is not directly transmitted. We are improved into 230 or the 400 kV system, at least 110 kV. So suppose if the plant has been the CHP plant, combined heat power generation plant, they are using the 11 kV up to 110, and the nearby SS is supplied. Suppose if it is in the low power hydel power plant, they are 11 kV to 230 kV. Suppose in very high the thermal power generation, nuclear power generation, they are having a large megawatt rating. They are minimum 250 to 1000, 2000, and 3000 megawatt rating. So that high power megawatt rating, we are ready for the reduction of the current carrying conductor size. We are introducing the 400 kV, right? So the 400 kV transformer, that is a step up from the whatever it is 11 kV to 400 kV or to 30 kV. Again, it may be going to be transmitted by the transmission line. So this is the transformer. So this is the step up transformer. This transformer also called as a power transformer. Already you are studied in the machines. For the measurement purpose, we are utilizing a mini transformer, that is the instrument transformer. So that both are different, different characteristics. Already you are studied in the measurement and instrumentation, right? So high voltage protection and sending and receiving end. So here two transmission line path, it can be merged with the one tie line bar, tie line bus coupler. So why we are going to introduce? Because we need the reliability of the power supply at the tail end. So whenever this transformer, it may going to fail due to some other failure or some other reason. So the power supply is maintained from this place, from this CB transformer CB. Again, it may be going to here. Again, it may go into this line, up to this line. It may be come here, right? And also the as usual, this is the CB transformer. Again, that the buses which is available. Again, it is the transformer buses. Then distribution feeder. So this is the way of that the entire protection scheme which can be implemented. Please see this bus bar which can be overlap with the two set of feeders. This is one feeder. This is one feeder. So both the feeder cities which can be protect this. It is a very highly useful one. At the same time, if you are not properly setting the relay coordination time tripping value, the system which can be create the nuisance tripping. So that is the problem. Okay. So if the system is, if you are not setting the proper tripping time, again this overcurrent will also going to announce. That is the problem in here. Again, this overcurrent relay which can be identified, the problem is occur here. Again, the unnecessarily this bus coupler is tripped. So to avoid this problem, the numerical relays we are introduced the nowadays the computerized based relay systems and SCADA. So many technology. The current technology is a PMU, right, which can be introduced, right? So this is the way. Then the next point is, what is the next point? The zones overlapping. Okay, overlapping of the zones. Zones. Why we are going to overlapping? That is the during the faulted conditions, the protective device which may be going to act as a primary and a secondary protections. Okay. Now, we are going to see the basic concept of earthing and grounding. What is mean by earthing? What is mean by grounding? We are going to see practically something else is different. First, I am going to give theoretically. So, earthing. This method which can be protect the human beings. Suppose in your home, so many electrical apparatus you are used in the day-to-day life. Day-to-day life, you are utilizing the so many electrical apparatus in the home appliances. Assume this is one right. Assume this is one of washing machine. Washing machine, okay, which is available machine. Suppose due to some other reason, due to the induction effect, the body of the machine which can be energized by the electrical potential. Suppose the human being which may going to uh, uh, touch this position, touch this the body of that machine, they are immediately realized by the electrical shock. So we want to bypass this inductive energy. We want to bypass. So we want to bypass this inductive energy to the ground, to the ground. So this is the one way. This is the one way. So this method is called the earthing. Okay. So which means the unwanted. The first thing is unwanted uh, inductive energy. Unwanted, that is the inductive energy or charged energy in the body. Okay, in the body. So one, the next point is, that is the due to loose connection, loose connection, or suppose if you are using in the coils, heating coils, that the heating coil, coil heaters, this is the coil heaters. Suppose if you are used in that the induction stove, also induction stove, this is the coil which may going to, if the coil is cutting and then it can touch with the body. This is a induction heating, and also the electrical filament based heaters, electrical electrical filament filament based heater. So it may create the, that is induced charge, that is the charge it can be created, which means the electrons flow through the body. So whenever the human boy being going to touch this body, the entire electron flow through the human's body. Again you are realizing the electrical shock. So to avoid this, we are going to earth, you are going to neutralize the this charged potential. The technical term is charged potential. This is the charged potential. Okay, suppose if you are going to any SS substation, the main SS, they are erecting the fence of the transformers also. Why? The charged potential is created around that. Suppose if you are enter into that session in the poor weather condition, you may going to immediately affected by the charge potential created in the weather. So but it is very very rare condition, but it may occur in the world, some places. Okay, so this concept is what I'm going to say, earthing. Now, what is mean by the grounding? Suppose in three-phase system, please assume in the three-phase system, this is the transformer. Yes, this is that the transformer. Yes, this is the neutral point. This is the neutral point. Basically, neutral point is used in black. Yes, this is the neutral point. This is the neutral point, which may going to taken as ground. Okay, so why we are going to suppose, if the neutral point is not grounded, it's not grounded, the voltage is accord between this point, it will be normally, that is a 230. If it is not accord, it may be accord the phase voltage. This is the phase voltage. This is that this is the phase voltage. This is the line voltage. So whenever the neutral point is disconnected, whenever the neutral point is disconnected, so again that is the potential across this winding, or it can be going to act as a phase to line voltage. So this type of neutralization, that the supply, whatever the supply in the neutral point, it can be taken as a grounded or a thing, is called neutral grounding systems, neutral grounding or grounded neutral systems. So both the schemes is differ, both the schemes. So you should not confuse with the This is grounding. This is grounding. This is called earthing. Okay. So are you able to understand? Anyone? Are you able to understand? Hello? Are you hear my voice?
Yes, sir.
Okay. So that is that the earth wire is used in green color. Normally, the earth wire used in that green color. Already you are well known. The grounded wire, the transformer, which can be the grounded wire, which can be used in the black color. This is a normal thing. The earthing is primarily to use to avoid the stacking. The already I have told to avoid the charged potentials, leakages, electrical leakage current can be neutralized, grounded through the some wire. Grounding is primarily used for the avoiding that the unbalancing of the electrical overload. So this is the word is very important. You should keep it in your mind. That is unbalancing. So this is the problem. For to avoid this problem we are going to utilize this. Okay. So next one is earthing is located under the earth pit between the equipment and the body. So how they are going to identify the earthing is located under the earth pit between the equipment body. So which means they are going to take the charged potential current through the separate wire and then taken as earth. They are using earth bit and then going to neutralize the flow of electrons. It is located the neutral of the equipment used in the ground. This is a separate ground they are using. Suppose if the please see the distribution transformer SS place in your residential area, that is 11 kV to 400 volt transformer structure which is available. Okay. So they are run the two earth bits, two uh, two grounded earth bits wires. Okay. So they are run in the uh, two things. So they are having some currency stones. Okay. So one is from the body earth, one is from the body earthing. Another one is neutral ground. So this neutral ground is very danger one. Is very danger. If the earthquake is not properly connected, the entire return current return path will also going to flow to your body. It is create more hazards, and these options which can be going to clear. So this may be explained with the help of one simple slide. Yes, please see this slide. This is the human being. Yes, this is the human being. Live wire. This is neutral wire, which means the one phase secondary distribution. This is a one distribution transformer is there. Distribution transformer output is one is phase and another one is a neutral. As per the suggestion, the neutral is grounded by using the ground wire, using the block. So whenever that it may be going to connected to the electrical system in the electrical apparatus, okay, electrical equipment. Whenever I am going to touch this the electrical apparatus, if it is the leakage is available, the charge current which may be flow to the human body and then it will be taken as a return path. This is the base case. So suppose if it is that is when I am going to earth it, okay, please see, please write. So whenever suppose I am also going to taken as here going to earth. Earth. So during that time, that current which may be going to flow here. Okay, so this is which may be going to flow here. So the human body, so this resistance, the human body having some resistance. So assume the 20 ohms for explanation purpose. This is a zero point 0.5 ohm or 1 ohm. The current will also going to choose the lowest resistance path. Okay, lowest resistance path. This is which may be going to lead the system which can be protected from the what I'm saying, that is the human being is protected from the electrical shocking hazards. So this way the fault current passes through the human body. Now the fault current is passes through the into the ground part. So the human being is to be uh, protected. The human being is to be protected. So this is the way. This is the way we are going to give protect our system. So this ground is a neutral grounded system. This connection of the neutralization of the electrons is the earthing system. Now you can identify what is meant by the grounding, what is meant by the earthing. Okay. Now I am conclude that is the today's class we are cover the zones of protection, zones of protections. How what are the zones is occur. Next one is what is mean by the earthing, what is mean by the grounding. Okay, it's white. First, follow I am going. Ground.